All right, guys, let's take a look at this limit here. Why don't we put in 0 into the numerator and denominator and see what we get, and that'll help us guide us in our direction of how we're going to solve this. When I put 0 in the top here, I get e to the 0 minus 1, which is 1 minus 1, which is 0. When I put 0 in the bottom, I get 0 times e to the 0, which is 0 times 1, which is 0. So this form, the limit has the form 0 over 0, which is in an indeterminate form. So we should maybe, we could do L'Hopital's rule. Now, there's a little trick here, but I'm not going to say it right away. There's a way we can save ourselves a little bit of time, but I'll tell you that later. Let's do it the long way first. So since it's 0 over 0, we are allowed to use L'Hopital's rule, so let's do that. The derivative of the numerator is, the derivative of e to the x is e to the x, and the derivative of that is minus 0. Remember that when you use L'Hopital's rule, it has nothing to do with the quotient rule for derivatives. L'Hopital's rule says that you just do the derivative of the numerator and the derivative of the denominator completely separately, and those two limits will be the same. Alright, so we've completed the derivative of the numerator. We still have to do the derivative of the denominator. To do that, we're going to have to use product rule, right? Because it is a product. The derivative of x is 1. Then I leave e to the x alone. Now I leave x alone, and I multiply by the derivative of e to the x, which is e to the x. And there we go. Let's see what we can do here. Why don't we write it a little bit nicer, get rid of the unnecessary stuff. I'm seeing that there's an e to the x everywhere. I can actually cancel that all out, right? But why don't I go just a little bit slower? What I'll do first maybe is factor out the common factor of e to the x in the denominator. So it'll look like this. And then you cancel. This step I just did is optional. You can go directly to what I have here. And just remember, when you cancel something, you leave a 1 behind, right? So there's a 1 here. And there's really a 1 here as well, but 1 times anything is just that thing, so I'll just leave it as that. And here we go. We're ready to say the answer. It's, we actually at a stage now where we can just put the number in, right? So let's do that. And when I do that, I don't write the limit sign anymore. And we have our answer. It's 1 over 1, which is 1, right? So the limit is 1. Great, that's the answer. Now, one thing I'll just mention is that, why don't I give another little way of doing it? It's the same, pretty much the same thing, but let me do it again. So here's another way. Let's see. You know, what if I wrote it like this? This 1 over e to the x, why don't I bring that to the front? And then I have this. And the thing is, why don't I put brackets as well? You know, e to the 0 is 1, right? If I put 0 in here, I get 1 over 1. And that's perfectly acceptable because the bad thing occurs when I have 0 in the denominator, which is what I have here, right? So, and I'll even put another set of brackets here. And what I'm going to break this up. I'm going to use the product rule for limits, which just says the limit of a product is the product of the limits, right? And this limit here, the first one, is easy. All I have to do is just put the number in. And the reason I'm allowed to do that is because the denominator is not 0. If the denominator is 0, I'd have to do something else. But this is perfectly fine because this is just really 1 over 1, which is 1. But here, I'm going to use L'Hopital's rule on this one, okay? It's of the form 0 over 0, right? When I put 0 in here, I get e to the 0 minus 1, which is 1 minus 1, which is 0. And, of course, if I put 0 in x, I get 0. So whenever you have 0 over 0, you are allowed to use L'Hopital's rule. If it's not 0 over 0, though, then you cannot. Well, if it's infinity over infinity or minus infinity over minus infinity, those are the cases you can use L'Hopital's rule. Otherwise, you can't. So let's use L'Hopital's rule on this one. The derivative of e to the x is e to the x minus the derivative of 1, which is just minus 0. And the derivative of x is 1. So we have that. Notice on this limit I dropped the limit sign here, right? Because I actually evaluated the limit. But on this limit I did not get rid of the limit sign yet because I'm still working on it. Alright, so like I said, e to the 0 is just 1. Over here on this limit here, the denominator of 1 isn't doing anything. It doesn't. So why don't I just write e to the x here? And now we're pretty close to having it done because we can just write 1 times, you know, this limit is now ready. I can now put the number just in. So I get 1 times 1, which is 1. And that's the same answer I had before, right? So I gave 2 solutions for this problem. It's up to you which one you prefer. Both are perfectly acceptable.